Hello students, welcome back to the another session of our artificial intelligence. In this video, we are going to learn what is a bidirectional search. Bidirectional search is an efficient search technique used in the field of artificial intelligence by the problem solving agent or goal based agent to extract the shortest path between initial stage to the goal state. Let's start. So as we know, this is one type of uninformed search or blind search means no information is given, only how to traverse the information given. So bidirectional is a one type of blind search. As per the name bidirectional means both the direction it can search. So this algorithm starts searching both the way means first one from the goal node, another is the from the start node. The one searching is started from the initial stage to the goal state, which is called as the forward search. Another search start from the goal state to the initial state, which is called as the backward search algorithm. So both the forward search as well as the backward search algorithm execute parallelly. So that what happened? The execution time is reduced by half of it. The searching process terminates when both the process, that is forward to search and backward search process, meet at each other at a intersection point. So at that time it will terminate, and we concluded the optimal path from the root to the start node to the goal node. This is generally used in case of graph where the graph size is too large. At that time, we are going to cover the bidirectional search, because if the graph is big size and we start from start node to the goal node, the time consumption is more and it is difficult to. That's why at that time we are going for the bidirectional search, which reduce the time as well as the reduce the memory requirements. So whenever the searching process start, that is the forward or backward, it can use the depth first search algorithm or depth limited search algorithm, or it can use the breadth first search algorithm. Any searching algorithm can be used. Only thing is that it will start the searching algorithm two way. First one is the from the start node, second one is from the goal node. So time consumption is less. Next, we have to understand how the bidirectional search algorithm works. So, for example, this is the graph is given. We have to perform the searching operation, that is any goal node we have to achieve. So, what are the steps is that to follow? First one is the initial startup, that is two search process start simultaneously, one from the initial to the goal, another one is the from goal to initial. Second one is the node expansion, means how the node, both the search, that is forward search as well as the backward search, alternatively expands the nearest unexplored node as per the searching algorithm, such as depth first search or breadth first search or the depth first. Means both the alternate, means first one move is done by the forward search, then another move is done by the backward search. Again back forward, then backward, forward, backward, forward. Alternatively, they start the expansion. Next one is the checking intersection. After each expansion, it checks if any newly created node present in the frontier of the opposite source. So why? Because we have to check whether it is the intersection point or not. For that, we have to check. Then we have, once the intersecting point is discovered, means now after checking the intersection point, once it is achieved, means this is the point, this or this is one node is the intersection point is discovered, then the node acts as an interconnector. So intersect point, so this node is as an intersection point. And what happened, how to calculate the, so optic path is generated by joining the path from initial node to the intersection point and intersection point to the goal node. Then we will find out our optimal path. Now let us understand this example, how it's performed over its operation. So now our goal node and initial node, that the starting node, we have to find out. For example, our initial node is the 3. Goal node is, for example, it is 18. So initial startup means here what happened? Two way we have to search. So this is our initial node, this is our goal node. This is our goal node, this is our initial node. Now So we have to start from this place and this place. Here we can use the BFS algorithm or DFS algorithm or depth limit search algorithm. Any algorithm we can able to use, but parallelly. So node first we have to initially then go for the node expansion. Node expansion means each and every iteration, each and every step we have to traverse from one node to the another node. For example, we have to go for the BFS. Then what happened from this node? What are the possible path? Only one path is possible from 3 to 6. So it moves from this to this one. Then it from here what happened? This is the goal node from the this node. What are the possible path? Only one path is present from 18 to 16. So it will traverse this way. So both the first this one, then this one. Then it will perform alternatively from this node. What are the possible way? There are multiple possible ways present. So here what happened? For example, we traverse in this way. Then it will traverse next way. Then it will traverse this way. Then it will traverse to this way. Now this is the intersection point. So once we go, so each and every iteration it will check. So once we got the intersection point, so which one? That is the 10. So 10 is the intersection point node. Then how to path the goal? So we have to start from this is our forward direction, this is our backward direction search. So what is the path right now? Path is 3 to 6, then 6 to 9, then path is 9 to 10, then intersection to the goal node. Then it is 10 to 14, then 14 to 16, then 16 to 18. Now let us understand how the searching algorithm is going to be implemented. What happened? We have required two stack. For example, this is one stack, another stack. Why we require two stack? One stack for the forward search, another one is the for the backward search. For example, our initial node is the 0 and goal node is the 14. So this is our initial node, this is our goal node. So right now what happened? It will traverse forward direction, it is the backward direction. So for example, this is for forward direction, this is for backward direction. So as we know, first we have to start from this node. So we push the 0. Then what happened? First we have to push here. Now here we have to push the 14. Now we have to make the 0 as a visited node and we have to make the all the successor we have to push here. So now I make this one as a visited here. Then all the children. Children means it has only one children, that is the 4. Now 4 insert into this one. Now this one 14, 14 will be removed from 14. Next successor. So what is the next successor? That is the 10. So here we have to remove the 14 and 14 we have to make as a visited and we have to push the successor node. So here it is 14. Now it travels to this one. So this travels to this one. Then next we have to remove the element or pop the element from the stack and make as a visited and we have to push all the successor. From the 4 successor is only 6. So now we have to remove 4 and push the 6 and we have to make the 4 as a visited node. Similarly, after the next what happened here also 10 is present. We have to take make we have to pop the 10, make as a visited node, and we have to push which value? Next successor. Successor is 10. So now successor is 8. So now we have to push 8. Now this tax. So we have to pop the element and make as a visited node and push all the successor. Successor is 7. So now successor is 7. Similarly, for backward direction, what happened? Backward direction search. Right now, we have to make the 8 as a visited node and we have to pop the 8 element, and we have to push the all the successor. Successor is 7. Now what happened? We have to remove this one and we have to make this is 7. Now during this, that each and every, after moving each and every forward expansion, what happened? We have to check whether it is a intersection point or not. Now it is a intersection point. So this is our intersection point. So once we got the intersection point, so we have to find out the path. Path means optimal path is from forward direction from the start node to the intersection point. 7 is the intersection point. So path here is 0 to 4, 4 to 6, 6 to 7. Then from intersection point to the goal node. So point 8, then 10, then 14. So this is the way the implementation is going to. If the binary the directional search use the DFS, then what happened? 2 queue we required. Here we require 2 stack for implementation, 1 stack for the forward search, 1 stack is for backward search. But if you are performing the bidirectional search by using the breadth-first search algorithm, at that time we also require 2 queue, 1 queue for the forward, another queue for the backward. If we are using the depth limit search, at that time we require 2 stack, that is one for the backward, another is for the forward direction. So let's understand what is the time complexity of this algorithm. This algorithm we are performing parallel execution of the forward direction search as well as the backward direction search. So the depth is divided by 2 here. So time complexity is order of b to the power d by 2, half of the depth, where the b is the branching factor of the search tree and d is the depth of the goal node. Then space complexity, here also space complexity, because searching is doing parallelly. So memory requirements also reduce. That is the half of the depth. That's why it is order of b to the power d by 2. Next one is the optimality. It's provide the optimal solution if breadth-first search is used for search and each edge has the same cost. So there are two conditions. If the searching strategy, because we know bidirectional search, we can use the depth-first search, we can use the depth limit search, we can also use the breadth-first search. But breadth-first search always gives the solution if there is solution exists. So that's why if we are using the breadth-first search as well as each and every cost associated with the edge present inside the graph is same, then it is definitely give the optimal solution. Then completeness. It provides optimal solution. It provides complete solution if the BFS is used for both the search, that is for forward direction search as well as the backward. It is not mandatory that if we are using breadth first search, we have to use both the for the both backward direction as well as the. It is our choice. That's why we can get the solution or it can be complete if we are using the breadth first search algorithm for the forward direction search as well as the backward direction search. So next, what are the advantages of these algorithms? It requires less memory. Reason is that parallel execution is going on, so memory requirement is half of the previous algorithm like the DFS, BFS and DLS. It is very fast compared to the other algorithms. If the graph is very large, then it is very useful to find out the shortest path without divided. That's why this algorithm provides the shortest path. Here the node expansion is less, so it is useful or very helpful for certain case where the cost of expansion node is high. There are certain situations where the expansion of node is very costly. So here it is the very less is required. That's why the cost wise is it very less. So let us understand what are the disadvantages. As we are executing the parallel execution, that's why the implementation is very complex. As we are already know, if we are using the breadth first search, we require 2 queue. If we go for the depth first search or depth limit search, then we require two stacks for implementation. That's why there is very complexity exists in case of implementation. Also, for backward direction, we require the goal state. So prior information of the goal step is required for in this case. These are the two disadvantages of this searching algorithm. Hope you are able to understand the concept of the bidirectional search. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel.